We are going to start now the next chapter, chapter 7 of class 11th mathematics, permutation and combinations, and this is lecture 1. So in this lecture we will talk about the definitions related to permutations. So first definition we have, it is factorial notation. The first definition we are talking over here, it is factorial notation. So we are saying, suppose we have any positive integer n. We are talking about any positive integer n, and we are writing corresponding to this integer, we are writing it is n into n minus 1 into n minus 2, so on up to 2 into 1. We are taking the continued product over here. For an example, suppose I am saying 6 factorial. The notation for factorial, it is in this way. We are saying we can write it as n factorial, or sometimes it is written as like this. So you can use any of these notations for factorial. So when we are writing 6 factorial, we can write it in this form, or we can write it as 6 factorial. So it is basically 6 minus 1 is 5 into 4 into 3 into 2 into 1. If we are talking about say 9 factorial, we are saying it is 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So if we look at this part over here, we are saying 1 into 2, 3 into 4 into 5 into 6. Look at this part over here. So what we obtain from this is that 9 factorial, we can also write it as 9 into 8 into 7 into 6 factorial. So this is just a notation. So the formula for this, the general formula, we are saying that for any integer n, we are writing n factorial is equal to n into n minus 1 into n minus 2 into n minus 3, so on up to 3 into 2 into 1. And if we talk about these terms over here, these terms, it is n minus 1 into n minus 2 into n minus 3, so on 3 into 2 into 1. So the answer we are writing it is n into n minus 1 factorial. We are saying the formula, first formula corresponding to factorial we have, it is n factorial is n into n minus 1 factorial. This is the formula for factorial that we have. Another important result that you should remember is that if we are calculating the value of 1 factorial, the answer we have, it is 1. We are saying n factorial, it is n into n minus 1, so on up to 1. So when we are talking about 1 factorial, the answer we have, it is 1. And if we have to calculate the value of 0 factorial, then we are saying that we can use the formula that n factorial is equal to n into n minus 1 factorial. So if we are calculating the value of 1 factorial, we are saying it is 1 into 1 minus 1 factorial. So we are saying 1 is equal to 0 factorial. So these values you should remember, that whenever we have 0 factorial, its value is equal to 1. Next is the problem based upon this. So first is 10 factorial over 7 factorial into 3 factorial. 10 factorial, we can write it as 10 into 9 into 8 into 7 factorial. The terms will continue like this up to 1, divided by 7 factorial into 3 into 2 into 1. This 3 into 2 into 1, this is value of 3 factorial. This 7 factorial and 7 factorial gets cancelled, and these values we are saying the answer on solving this is 4, this is 3, so the answer we obtain, it is equal to 120. Similarly, in the next question we have, it is 30 factorial over 28 factorial. Answer we obtain, it is 30 into 29 into 28 factorial divided by 28 factorial. These two terms get cancelled. Answer we get, it is 30 into 29 is equal to 870. Next we have is 11 factorial minus 10 factorial divided by 9 factorial. I can write this 11 factorial as 11 into 10 factorial minus 10 factorial divided by 9 factorial. This is equal to 10 factorial into 11 minus 1 by 9 factorial. This 10 factorial we can write it is 10 into 9 factorial. These two gets cancelled, and the value of this term over here it is 10. So the answer we get it is 10 into 10, that is equal to 100. Next is, if x upon 10 factorial is equal to 1 by 8 factorial plus 1 by 9 factorial, then we have to calculate the value of x. So we are writing it is x is equal to 10 factorial by 8 factorial plus 10 factorial by 9 factorial. We have multiplied both sides of this term by 10 factorial. So this is equal to 10 into 9 into 8 factorial divided by 8 factorial plus 10 into 9 factorial divided by 9 factorial. This 8 factorial gets cancelled, 9 factorial gets cancelled. We are left with is 90 plus 10 is equal to 100. So the answer we obtain it is 100. Next is express the following products in factorials. So the first part we have it is 5 into 6 into 7 into 8 into 9. So what terms we are going to add over here? It is 4 into 3 into 2 into 1, and we are going to divide it with 4 into 3 into 2 into 1. Now look at this complete term. This complete term numerator part we are saying this is equal to 9 factorial divided by the denominator we have it is 4 factorial. Next we have is 2 into 4 into 6 into 8 into 10. Now from each of these terms we are saying this is 2, this term it is 2 into 2, this term this is 2 into 3, this term it is 2 into 4, this term it is 2 into 5. So from each of these terms we have this is first, second, third, fourth and fifth. We are saying we are having 2 raised to the power 5 into 1 into 2 into 3 into 4 into 5, and this value is equal to 2 raised to the power 5 into 5 factorial. Next is find the LCM of it is 5 factorial, 6 factorial and 7 factorial. So we can write this is equal to 5 factorial, next is 6 into 5 factorial, and next is 7 into 6 into 5 factorial. The next value we will have 7 into 6 into 5 factorial. So from all these terms we are saying we can take 5 factorial common. So the terms we are left over here it is 1, 6 and 42. Now we are talking about the LCM of these three terms. We are talking about the LCM of these three terms, and the LCM of these three terms will be 42. So the answer we obtain it is 5 factorial into 42. We can write it as 5 factorial into 6 into 7. So the answer we have that is equal to 7 factorial. Next question we have is n plus 1 factorial is equal to 90 into n minus 1 factorial. We have to calculate the value of n. So the terms we have over here it is n plus 1 factorial. We can write this is equal to n plus 1 into n minus 1 factorial. Now this term it is being given that n plus 1 into n minus 1 factorial, this is equal to 90 into n minus 1 factorial. Clearly this term we are saying it is not 0. So this implies us that 90 is equal to n into n plus 1. So this is equal to now the next question we have is if n plus 2 factorial that is equal to 60 into n minus 1 factorial, we have to calculate the value of n. So we can write this n plus 2 factorial as n plus 2 into n plus 2 minus 1 will be n plus 1, then minus 1 we will do it as n into n minus 1 factorial. This is equal to 60 into n minus 1 factorial. So basically what we have to do is we have to calculate some natural number which satisfies n into n plus 1 into n plus 2 is equal to 60. So we are saying that 3 consecutive natural numbers we have to calculate, whose when we multiply these numbers we get 60. So when we substitute n is equal to 3, we are getting it is 3 into 4 into 5 is equal to 60. So we are saying that the value of n in this case it is 3. Next is prove that n factorial plus 1 is not divisible by any natural number between 2, 3, so on up to n. So we are saying that if we talk about the number n factorial, it is equal to n into n minus 1 into n minus 2, so on up to 3 into 2 into 1. Now, this number when we are talking about, this is divisible by all the numbers 2, 3, 4, so on up to n. It means when we divide n factorial with any of these number, remainder will be, the remainder is equal to 0. It means if we divide n factorial plus 1 with any of these numbers, remainder will be 1. It means none of these numbers divides n factorial plus 1. Now next we have to prove that n into n minus 1 into n minus 2 so on up to n minus r plus 1, this is equal to n factorial over n minus r factorial. So if we look at this term n factorial, we can write it as n into n minus 1 into n minus 2 so on up to n minus some number r is there. Next it is, the next number to this will be n minus r minus 1 so on up to 2 into 1 divided by n minus r factorial, and the number before this number over here, the number we will have, that will be n minus r plus 1. So we are saying that this term, look at this term over here, we can write this term as n minus r factorial. So we are getting that n factorial is equal to n into n minus 1 so on up to n minus r plus 1 into n minus r factorial divided by n minus r factorial. These two terms gets cancelled, so we obtain the answer in this form, that n into n minus 1, n minus 2 so on up to n minus r plus 1 factorial is n factorial divided by n minus r factorial. Next we have to prove is that 2n factorial, it is 2n factorial divided by n factorial, it is equal to this term. So if we talk about this numerator part over here, I am talking about 2n factorial, I can write this is equal to 2n factorial means we are talking about some even number is there and we are taking its factorial. So we can write it is equal to 2n into 2n minus 1 into 2n minus 2 so on up to 2n minus n plus 1 2n minus n 2n minus n minus 1 so on up to 3 into 2 into 1. We are saying that we have the numbers in this form. Now we can separate these numbers as even and odd. We are saying we are writing it is 2n into 2n minus 2 into 2n minus 4 so on up to 4 into 2. These are the even numbers out of this, and odd numbers will be 2n minus 1 into 2n minus 3 so on up to 3 into 1. Now how many digits we have over here? We are saying this is 2n, this is 2n minus 2, 2n minus 4, 4, 2. So total number of digits we have over here, it is, these are n terms. Out of each term, all these terms, these are even, we can take 2 common. So if we take 2 common, I am talking about this term, if I will take 2 common from these terms, I will get 2 into 2 into so on up to n times it is 2. N into n minus 1 into n minus 2 so on up to 3 into 2 into 1. This is the first term we are talking over here. This portion I am saying if I will take 2 common from this, I will have 2n times, and the remaining terms will be in this form. The remaining terms will be in this form. Now this 2n times we can write, this 2 we are writing n times, we can write it is 2 raised to the power n. These terms we are saying, these terms, this will be n factorial, and the remaining terms we have over here, look at these terms over here, these are odd terms we have. So we are saying that when we divide this value with n factorial, in this question we have to divide it with n factorial. So this n factorial gets cancelled, this n factorial gets cancelled, and we are left with is 2 raised to the power n into 1. These odd terms are there, these odd terms we are saying these are left, into 3 into 5 so on up to 2n minus 3 into 2n minus 1, and this is the required answer. So this is the value in this case. Next is prove that n factorial square, we have to prove that n factorial square, it is less than equal to n factorial into n raised to the power n, and it is less than 2n factorial. So we start with this term, we are saying n factorial square, this is equal to n factorial into n factorial, this is equal to n factorial into n minus 1 so on up to 3 into 2 into 1. Now each of these terms, these are less than n, so we can write it is less than equal to n factorial into n so on up to n. How many times n are there? This is n times. So this is equal to n factorial into n raised to the power n. So this is the first part that we have to prove, that n factorial square, it is less than equal to n factorial into n raised to the power n. Now to prove this second part, we are talking about this inequality. We are starting with the term 2n factorial. The value of 2n factorial we will have it is 1 into 2 so on up to n into n plus 1 into n plus 2 so on up to 2n. Now look at these terms over here. We are talking about this portion. All these values, these are greater than n. So we are writing it is this term we have, it is greater than or equal to 1 into 2 so on up to n into n so on up to n. All these values, these are, we are saying n plus 1 is greater than n plus 2 is greater than n, so on up to 2n is greater than n, because n is a natural number we are saying. So these terms we are saying these are n times. So this whole term we can write, this is equal to n factorial into n raised to the power n. We are saying this is n factorial into n raised to the power n. So this thing proves this second part of the inequality. This thing proves the second part of inequality. So by combining both these results, we are saying 2n factorial is greater than this term, and n factorial square is less than this term. So by combining both these results, we obtain this whole inequality. So we have listed some important properties over here. The first property we have already seen, it is 2n factorial. It is equal to 2 raised to the power n into n factorial into 1 into 3 into 5. These are the product of the odd terms less than 2n. Next we have is n factorial divided by r factorial. We are saying where r is less than n, it is some number. So we are saying that this n factorial, we can write it as n into n minus 1, so on up to, we are talking up to this number r. So r is less than n. So some number r plus 1 will be there. Then after this we will have r factorial divided by r factorial. You can just look at this in this way. We are saying that 7 factorial over 2 factorial. So I am writing it is 7 into 6 into 5 into 4 into 3 into 2 factorial. So we are saying if we have some number r which is less than n, then we can write it in this form. So this r factorial and r factorial gets cancelled, and we are left with this answer that n factorial over r factorial, it is of this form. And if we are talking about the result in the form that n factorial over n minus r factorial, again we are saying r is less than n, so we can write it as n into n minus 1, so on up to n minus r plus 1 into n minus r factorial divided by n minus r factorial. Both these values gets cancelled, and we are left with this answer. Next is 1 over n factorial plus 1 over n plus 1 factorial, that is equal to lambda over n plus 2 factorial. We have to calculate the value of lambda. So we are saying that we multiply this whole equation, both sides of this equation, by n plus 2 factorial. So we obtain it as n plus 2 into n plus 1 plus n plus 2, that is equal to lambda. So this gives us, if we take n plus 2 common, we are left with this n plus 1 is equal to lambda. So this gives us that n plus 2 square is equal to lambda. So this result is over here. We are saying that lambda is equal to n plus 2 square. Next we have is if x factorial is equal to y factorial, then this implies us either x is equal to y, or we are saying x is equal to 0, y is equal to 1, x is equal to 1 and y is equal to 0. So we are saying that the final condition we have is that if x factorial is equal to y factorial, then either x is equal to y, or x is equal to 0 and y is equal to 1, or x is equal to 1 and y is equal to 0. So these are some properties we have listed over here. Next is find the remainder when sigma r factorial r is equal to 1 to n is divided by this term, it is divided by 50, and it is given that n is greater than equal to 5. So it is summation of these terms over here. So if we write these values, it is basically 1 factorial plus 2 factorial plus 3 factorial, so on up to n factorial, and it is being given that n is greater than equal to 5. Now we have to check the divisibility with 15. So if we write these numbers in this form, it is 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial and plus 5 factorial plus 6 factorial, so on up to n factorial. And we are separating these terms. We are writing it in this form that these are the separate terms we are writing and these are the separate terms we are writing. The answer for these values, it is 2 plus 6 plus, it is 1 plus 2 plus 6 plus 24. So the total value we get over here, it is 33. And if we look at these terms over here, this first term we are talking about, this first term we are saying it is 5 into 4 into 3 into 2. This next term will contain this, this next term will contain this. So all these terms basically contain these all terms, these are the multiples of 50. So the next step we are going to do is, we are saying suppose this number we are saying it is the number n we are talking about. This is the number n we are saying. We are writing n is equal to 33 plus these terms we are writing, these terms we are talking about, these are multiple of 15. Suppose I am writing this is equal to some number m into 15. So if we divide this number with 15, if we divide this number with 15, this will be the integer part over here, this will be some integer, or we are saying this number will be exactly divisible, this is m. So here we want to calculate the remainder. So the remainder will be same whatever will be left on dividing 33 by 15. So we are saying if we divide 33 by 15, the remainder left will be 3. We are saying that if we divide 33 by 15, the remainder left will be 3, and this will be the remainder obtained on dividing this number n by 15. Now next we have is the exponent of prime p in n factorial. So suppose we are talking about the number 7 factorial. So we know that the number it is 7 into 6 into 5 into 4 into 3 into 2 into 1. So if we look at the prime factors over here, we can write 7 factorial is equal to 7 raised to the power 1, then the 5 raised to the power 1, then 3 raised to the power 2. From this term and this term, we can write it is 3 into 2, and then it is into 2 raised to the power 1, 2, 3 and 4. So what this thing means is, when we are saying that the exponent of prime p, so exponent of 2 in 7 factorial, it is this number we are talking about 4, and this number if we are calculating, we are writing it is e to 7 factorial, we are saying it is equal to 4. It is, we are saying the power of that number, we are saying the power of that prime number when we are writing the prime factorization of the factorial. So the question we have is, find the exponent of 3 in 100 factorial. So if we are talking about 100 factorial, we can write it as 1 into 2 into 3 so on up to 100. Now if we separate the terms which are multiple of 3, we obtain it as 1 into 2 into 4 into 5 so on up to 100 into the terms which are multiple of 3, they are 3 into 6 into 9 into so on up to 99. Suppose this number we have over here, we are writing it is some k. So we obtain it is equal to k into how many total digits are there. These numbers we are not digits, we are saying how many total numbers are there. These are 33 numbers. These are 33 numbers. So from all these numbers we take 3 common. So we obtain it is 3 raised to the power 33. From this term we take 3 common, we are left with this 1. This term it is 3 into 2. This term it is 3 into 3. So if we have taken 3 common from each of these terms, we are left with is 1 into 2 into 3 so on up to 33. So we are saying from where this 33 we are getting, the total numbers we have it is 100. We are dividing it with the number 3, and we are saying the total number of terms we have over here, or we are saying it is 1, 2, 3 up to 100. We are dividing it with 3. The answer we obtain it is 33 point something. So if we are taking the greatest integer of this value, the answer we have it is 33. So this is the 33 we are talking about. This is the power 33 we are saying over here. Now we are left with this term. It is 1 into 2 into 3 so on up to 33. Again we are writing it is k into 3 raised to the power 33 into, again we separate it in 2 parts, 1 into 2 into so on up to 32. These are the terms which are not multiple of 3, and the terms which are multiple of 3, it is 3 into 6 into so on up to 33. Now suppose these numbers, these 1 into 2, these numbers which are not multiple of 33, the product of all these we are writing it is k1. So this will become k into k1 into 3 raised to the power 33. Now how many terms are these? We are talking about these terms. So it will be, we are saying the number of terms we require over here, it is the multiple of 3 from 1 to 33. So that will be 33 by 3, the greatest integer of this function. So the answer we obtain, it is equal to 11. So we are saying from all these terms, if we take 3 common, we will have 3 raised to the power 11 into 1 into 2 so on up to 11. Again for this term we are saying, we are writing, I am talking about this term only, we are writing it is 1 into 2 so on up to 11, and the multiple of 3, they are 3 into 6 into 9. These are 3 terms we are having now. So we are saying this number, this portion of number we are saying, and multiple of these two. Suppose we are writing it is k1, it is k2, multiple of, we are saying k into k1 into this, we are writing it is k2. Then these two power, these get added, we are saying it is 3 raised to the power 33 into 3 raised to the power 11. Then from these 3 terms we can write it is into 3 raised to the power 3 common, and we are left with is 1 into 2 into 3. So the power of 3 we have over here, it is 1. So the total value we have, the total power we have over here, we are saying it is 33 plus 11 plus 3 plus 1. Saying the total exponent of 3 we have, it is 48. So what we have noted over here, that these powers we are obtaining, these powers we are saying, the powers we are obtaining over here, 33, first value we are talking about, it is 33. It is basically, we are saying 100 by 3 greatest integer function. Next value we are obtaining, it is 11. So we are saying it is 33 by 3 greatest integer function. We are writing it is equal to 11. 33 we are obtaining from this term. So we are saying that this 33 by 3 we can write it is 100 by 3 square greatest integer function. Next value we will have, next value we are saying it is 3 raised to power 3. This 3 we are getting by doing 100 by 3 cube greatest integer function. So if we want to write the general formula over here, we are saying, suppose we are having the numbers 1, 2, 3 so on up to n, which are divisible by p. Then the last integer we have, the last integer among the numbers, we are saying the last integer among the numbers 1, 2, 3 so on up to n, which is divisible by p, is greatest integer of n by p into n. So we are saying that if we want to calculate the value of the exponent of p in n factorial, we can write it is equal to exponent of p in 1 into 2 into 3 into n minus 1. In place of n factorial, we are writing this term. Now look at these terms over here. We are saying it is 1 into 2 into 3 so on up to this. We can write it is equal to p into 2p into 3p into n minus 1p, and the last term we have over here, it is equal to n by p greatest integer into p. So if we look at this step over here, what we are doing, in the previous case we were doing it is 1 into 2 into 3 so on up to 99 we were having. So we have written it in the term 1 into 2 into so on up into 100. We are saying it is into 100 into 3 into 6 into so on up to 99. So if we look at these terms over here, these are of the form 1 into p, this is of the form 2 into p, then up to n by p into p. So this is the term we are talking over here. We are saying the exponent of n factorial, that will be equal to the exponent of this term, because this portion we have, it does not contain any number which is multiple of 3. So we are left with only this portion, and the exponent will be equal to the value we are having over here. So when we are saying exponent over here, exponent means we are saying it is 3 raised to the power 1 into 3 raised to the power 2 into 3 raised to the power 3, so on. So the powers are basically added over here, 1 plus 2 plus 3 and so on. So we are talking about these powers over here. So these powers, these are added. So we are saying when we look at this value over here, so the answer from this we are getting, it is equal to n by p, greatest integer, plus the terms we are left with is, it is exponent in the term 1 into 2 into 3 so on up to n by p, greatest integer. This is same as we have done in our previous example, that this value we were obtaining, it is 100 by 3 greatest integer. The answer we have obtained, it is 33. Over there we were writing 3 raised to the power 30. 3 we have taken common. So same thing we are saying, we are talking about the exponent. So we are saying 33 we have taken common over here. We are left with this term. We are left with this term. Now from these terms we are saying which is divisible by p is, the term which is divisible by p, it is in this form, that it is n by p square greatest integer. So we are writing this term, that exponent of p in n factorial, that is equal to greatest integer of n by p, greatest integer of n by p square. Then we have exponent of p in the term 1 into 2 into 3 so on up to n by p square. And like this we have to continue, in this way. We are saying we have to continue in this way, and we will move up to this term. It is, we are saying the last term we are left with is n by p raised to the power s, where s is the largest natural number such that p raised to the power s is less than equal to n is less than p raised to the power s plus 1. So this is the formula that you should remember, that is exponent of p in n factorial, that is equal to the greatest integer of n by p plus greatest integer of n by p square plus greatest integer of n by p cube so on up to greatest integer of n by p raised to the power s. So the next thing that we have over here, it is the number of zeros at the end of n factorial if we have to calculate. So that will be given by exponent of 5 in n factorial. This will give us the, suppose we are being asked that how many zeros will be there in the end of, say I am saying 13 factorial, or some larger number is given, say 27 factorial we are talking about. So what we have to calculate is, we have to calculate E527 factorial. The formula we have, it is equal to 27 by 5 greatest integer function plus greatest integer of 27 by 5 square and so on. The value we will have over here, it is 5. The value we have over here, it is 1, and all other values will be 0. So we are saying the answer we have, it is 6. So what we obtain from this is that the number of zeros at the end of 27 factorial will be equal to 6. Next is find the exponent of 3 in 100 factorial. So the answer we will have, it is 100 by 3 greatest integer plus 100 by 3 raised to the power 2 greatest integer, this power it is 2, plus 100 by 3 raised to the power 3 greatest integer plus 100 by 3 raised to the power 4 greatest integer plus 100 by 3 raised to the power 5 greatest integer and so on. Now if we look at this value, it will be, we are getting it is 33. Next we are dividing it with 9. So 100 divided by 9 when we are doing, it is basically 99 point 11 point something. We will have 99 over there. We will have the answer 11 point something. So we are saying the greatest integer, it is 11. Next it is 27 over here. So we are getting the answer, it is 3. Then this is 81. Answer we are getting 1, and all other values after this will be 0. The sum of all these values, is equal to 48. and this is the required answer, that is the exponent of 3 in 100 factorial. Next is prove that 33 factorial is divisible by 2 raised to the power 19, and what is the largest integer n such that 33 factorial is divisible by 2 raised to the power n. This thing we have to calculate. So first thing we have to calculate is that 33 factorial is divisible by 2 raised to the power 19. So if we calculate the exponent of 2 in 33 factorial, the answer we will have it is 33 by 2 greatest integer plus 33 by 2 square greatest integer, likewise and so on. So it is 33 by 2 means we are saying it is 16, then it is 4, so we get it is 8. Next will be 2 cube, so it will be 8, and the answer we obtain that will be 4. Next will be 2 raised to the power 4, so it is 16, the answer we obtain it is equal to 2. Next will be 2 raised to the power 5, answer will be 32, the answer we have it is 1, and after that we will have all the terms, they will be 0 after this. So the final answer we obtain, the sum of all these values we are saying it is equal to 31. So what we obtain is that the exponent of 2 raised to the power, we are saying the exponent of 2 in 33 factorial, that is equal to 31. It means that 33 factorial is divisible by 2 raised to the power 31. If it is divisible by 2 raised to the power 31, it means it is also divisible by 2 raised to the power 19. And the largest value of n, second thing we have to calculate is, first thing we are saying that it is divisible by 2 raised to the power 19, and second thing is what is the largest integer n such that 33 factorial is divisible by 2 raised to the power n. So we are saying the largest value of n is 31. This is the largest value of n. Next is find the number of zeros in the end of 100 factorial. So we know that the number of zeros in the end of 100 factorial, that will be the exponent of 5 in 100 factorial. So the answer we obtain it is equal to 100 by 5 greatest integer plus 100 by 5 square greatest integer plus 100 by 5 cube greatest integer. So this value we will have it is 20, this value we will have 4, and all other values they will be 0. So the answer we obtain that is equal to 24. This is the answer we have obtained over here, it is 24. So how we are getting this answer, we can see from these terms. So we are saying if we calculate the exponent of 100 factorial, 2 in 100 factorial, the answer we obtain it is 97. If we calculate exponent of 5 in 100 factorial, the answer we are getting it is equal to 24. It means we are saying that 100 factorial we can write it is 2 raised to the power 97 into 3 raised to the power some power will be there into 5 raised to the power 24 into 7 raised to the power some number will be there, and so on. We are talking about the prime factorization over here. Now 10 we will obtain by the multiplication of these two terms. We are saying the powers we have over here. So we will obtain 10 when we will write it is 10 raised to the power 24 basically we will have, and rest of the terms we are left over here, that will be 2 raised to the power 73, 3 raised to the power b we are writing. Suppose these values we are saying b, this value we are saying it is d, and so on. So we are saying these are basically the exponent of 5 in 100 factorial, that will give us the value of the number of zeros in the end of 100 factorial. Next is for how many positive integral values of n does n factorial end with precisely 25 zeros. So suppose we are saying the number n we are talking about the exponent of 5 in n factorial, the answer we require it should be equal to 25. It is given over here. So we are saying the value of this term will be n by 5 greatest integer plus n by 25 greatest integer plus n by 125 greatest integer and so on. Now suppose we substitute the values of n. We want to calculate the value of n for which this term, the sum of all these terms should be 25. Though the first thing, it is clear that n should be greater than 25. So suppose we substitute n is equal to 25. If we substitute n is equal to 25, the answer for this term we will have it is 5, and the answer for this term that will be equal to 1, and all other terms will be 0. Now suppose we substitute n is equal to 50. So the answer for this term we will have, when we are substituting n is equal to 50, the answer for this term we will have it is 10, and the answer for this term it will be 2. So it is 12. Now suppose we substitute n is equal to 100. We substitute n is equal to 100. So the answer in this case we will obtain it is 20. When we substitute n is equal to 100, we are getting it is 20. And this value we are obtaining it is 4. Next we are substituting, say n is equal to 104. We are substituting n is equal to 104. The answer we obtain in this case it is again 24. In this case also the answer we obtained is 24. If we substitute n is equal to 105, the answer we obtain over here it is 21. The answer we obtain over here it is 4, and sum of these two values will be equal to 25. That is the required value. Similarly, if we will substitute 106, we will obtain the same answer. If we substitute 107, 108 and 109, we will obtain the same answer. If we substitute n is equal to 110, this first term will give us the value 22, and this second term we are saying it will give us the value 4, and the answer will become 26. So the possible values of n we have over here, they are 105, 106, 107, 108 and 109. So we are saying that the number of values we have it is equal to 5. The number of values we have over here it is equal to 5. Next is find the exponent of 80 in 180 factorial. So one thing is clear that this is not a prime. So we must find the factors over here. So the prime factors over here we have it is 2 and 5 we will have. Right, it is equal to 2 raised to the power 4 into 5. So if we calculate the exponent of 2 in 180 factorial, the answer we are getting, we have shown these calculations over here. You can see these calculations. The answer we are getting it is 176. The answer in this case we are getting it is 176. And the exponent of 5 in 180 factorial we are saying, the exponent of 5 in 180 factorial we are saying it is equal to 40. This value we are saying this is equal to 44. This value we are saying it is equal to 44. So what we obtain from this is that when we are writing the prime factorization of 180 factorial, we are having the terms in the form 2 raised to the power 176, then 3 raised to the power some power is there, and then continuing in this way we will have 5 raised to the power 44. Then next we will have it is 7 raised to the power something and so on. Now if we combine both these terms, we will have this is equal to 2 raised to the power 4 raised to the power 44 into 5 raised to the power 44 into 3 raised to power something into 7 raised to power something and so on. This is equal to, this value we are saying this is equal to 2 raised to the power 4 into 5 raised to the power 44 into 3 raised to power something, 7 raised to power and so on. So this gives us, this is equal to 80 raised to the power 44. This 80 we have already seen that this value is 2 raised to the power 4 into 5 into 3 raised to the power something into 7 raised to the power something. So we are saying that the exponent of 80 in 180 factorial, it is equal to 44.